All right, hello business calculus class. So we're going to go ahead and get started. This is going to be our last special derivative rule. This is your book assignment, this page 137 assignment here. We'll work on this during class. I would like you guys to do the do now problem as your warm-up. You will turn this in for a grade to me at the start of class. So please answer these, these 4 questions here. For this f3 to the negative 1 here, you're going to take f of x and you're finding the third derivative of this function, and then you will plug in -1 for x. And answer questions for number 2 here, answer A, B, and C as close as you guys can. We'll talk about this a little bit at the beginning of class, but you guys will turn this in for a grade. Alright, let's go to the next page here. So we have, how do we find this derivative? So what we're going over today is something called the chain rule. We're going to start off with the basics here. How would we go about finding this derivative as it sits right now? So let me switch over to the camera really quick here. So we have 3x minus 2 squared. So here on my sheet, let's adjust that a little bit. Okay. So we have f of x is equal to 3x. Let's focus that. 3x. There we go. 3x minus 2 squared. So right now, the only thing that you guys know how to do with this is you guys know to FOIL it out, turn it into a polynomial, and then use the power rule. So if we FOIL this thing out, we will get 9x squared minus 12x plus 4. Okay, when we FOIL the whole thing out, 3x squared, 4, that's -6, yeah, -12x squared. There. All right, if we take the derivative of this function, what we will end up with is 18x minus 12. Excuse me, guys. Okay, so 18x minus 12 for our final derivative for this particular problem. What we're going to learn is the chain rule. There's another way for us to do these. Like I told you guys before with the quotient rule and stuff, if you guys can ever do just some basic arithmetic to turn it into a simple polynomial, do that, because the power rule is by far our easiest way of finding derivatives. When we have more complicated functions, we want to start using the chain rule. And the chain rule is one that we'll actually use quite a bit, because we're going to see this concept of nested functions quite often. Speaking of which, before we get into that, you guys need to go think back to Algebra 2, to your pre-calc class, and we were doing composition of functions. So if I gave you, let's say I gave you h of x is equal to the square root of x, and g of x is equal to this, whatever, it doesn't really matter. Let's do x squared plus 2. Okay, so we have 2 functions. So you guys might remember this notation. We have h of g of x, where we're going to place g of x inside of h of x. Okay, so that would look like the square root of x squared plus 2. We have taken g of x, and we have plugged it inside of h of x wherever we had an x. Okay. Likewise, we have g of h of x. So we're going to place, wherever we have an x and g of x, we're going to plug in the h of x. So that'll give us the square root of x squared plus 2, which just simplifies into x plus 2. Okay. What we're going to be doing with the chain rule is it's how do we take the derivative of these things, because we can't simplify this into a polynomial. It turns out that we can with g of h of x, but we can't do with h of g of x. So this one's a little bit different. So there's some special rules that needs to happen for that, and that's where the chain rule comes in. So let's go to the next slide here. Let me close that. So if we go to the next slide in the presentation here, we're actually going to see the chain rule. The chain rule is this. This is really kind of confusing notation. It's accurate, but so the way this reads is the derivative with respect to x of a function of u is going to be equal to the derivative of the function and then multiplied by the derivative of whatever u happens to be. Another way of thinking of this, if I use this example that I did here, let's scoot this over here just a little bit. Just flip this around. So now let's not do that. So I have the square root of x squared plus 2. Let's do it that way. What this is really saying is that, think of this like an onion. So if I have the square root of x squared plus 2, okay, what I'm going to do is I'm going to take the derivative. So take the derivative of outer function, and then take the derivative of inner function. Okay, so for this particular example, the way that would look, if you guys want to remember here, we have two functions here. Our first function is the square root of x. I'm sorry, back up here. The first function, the outer function, is the square root of x, and we have x squared plus 2 on the inside. So what we're going to do is we'll take the derivative of the square root of x, which, as you will recall, we just pretend that x squared plus 2 is just like z or something. It's just some random value. Okay, so this is going to be the square root of x squared plus 2 all over x squared plus 2. Because if you remember, the derivative of the square root of x from the times we've done it just turns into the square root of x over x. If you guys don't remember that, go work it out really quick using the power rule. You'll see that's what it works out to. We're going to multiply that by the derivative of the inside. The inside is just the x squared plus 2 part. So that's just going to be 2x by the power rule. So we end up with that. So that's the derivative of this function. We're going to do a couple more examples of this one. This one's a little bit complicated here. This one's a little bit big and stuff. So we'll simplify that one out. All right, let's try another one here. Actually, let me give you another rule here. So another way to think of it is if we are taking the derivative of a function f of g of x, this will be the same thing as the outer function. So the first function we deal with will be g of x. We'll have g prime of f of x, and then we're going to multiply that by the derivative of f of x. Okay, so you have to identify what the outer function is. In this case, it's g. Okay, and then we're going to multiply that by the inner function, which in this case is f. So that's your general rule for. I like this a lot more than what's in the packet. The other packet's a more formal way of writing it, but they both work. So let me turn off the camera. All right, so we'll go back to the channel. Let's do an example of this. I'm not going to spend a lot of time doing this. Actually, I'm probably going to stop the video here in just a minute because I want you guys to do a lot of the examples that are in this packet. And we can look at some of these in class as well. I'm going to go through these 4 examples here, and then we'll probably end it. So let's start off with here. We've got 4x minus 3 cubed. Okay. We have an expand. Actually, do I have a cleaner one here? I really want one that I can multiply out. Hey, let's go back to that example that we had at the beginning here. So we had 3x minus 2 squared. Alright, let's do that one. So we had 3x minus 2 squared. Theoretically, it works out to 18x minus 12. Let's see if that's true. So we have 3x minus 2 squared. Okay. Our outer function is the quadratic. Okay, so this would be like our g of x is one way to think of it. And our inner function is the 3x minus 2. That's our inner function. Okay. So if I take the derivative of x squared, that's just going to be 2x, but x is this 3x minus 2 thing, so that's going to be 2 times 3x minus 2. The derivative of the inner function will just be equal to 3. So now if I multiply all of this together here, so we'll distribute through here, that'll give me 6x minus 4 times 3. And we'll distribute the 3 through. 3 times 6 is 18, so we get 18x. 3 times negative 4, 18x. 3 times negative 4 is minus 12, so we get 18x minus 12, which matches our answer from before. Okay, so that is the chain rule. I'm going to do one of the. I'll do a couple of the examples that are on the on the packet. Let's see here. We've got 4x minus 3, so we have f of x is equal to 4x minus 3 cubed. Okay, and let's work this one out, and then I'll probably end the video, and then if you guys have questions, bring them up during class. So we're going to take the derivative of the outer function, which is the cube. So we're going to bring the 3 down to the front. We'll have 4x minus 3, and then it just becomes squared. And then we take the derivative of the inner function, which will just be 4. So this whole thing, when we work out the derivative for it, will be equal to 12 times 4x minus 3 squared, which is something we can FOIL out to figure out its final value, which I'm going to ask you guys to do. Actually, I'll go ahead and do it because I'm going to ask you guys to do it. So this will be 12 times, this will be 16x squared. That's going to be minus 12 minus 12, so it'll be negative 24x plus 9. I won't do the distribution. I don't want to waste time with some of the arithmetic, but that's the idea behind doing the chain rule. So just remember, identify your outer function, the outer function, and then there's going to be a function inside of that function. Take the derivative of the outer function, keeping the inner function as your variable. Okay, and then you're going to take the derivative of the inner function, multiply everything together, and that's the chain rule. All right. If you guys have questions, bring them to me during class. Remember the warm-up, and we'll get through this tomorrow. All right. I'll see you guys then.